This is part 8 in our series of lectures on the principle of mathematical induction. And in this lecture, I'm going to give you an incorrect use of the principle of mathematical induction. I'm going to write a proof using mathematical induction of a result that is clearly an incorrect result, a false result. So here's the result that I'm going to prove using mathematical induction. Suppose we have a collection of stamps consisting of red stamps and blue stamps. I'm going to take a bag and I'm going to put some of the stamps in the bag. Then my claim is that if at least one of the stamps in the bag is red, then they're all necessarily red. In other words, it's impossible for there to be a blue stamp and a red stamp in that bag. Okay, and I'm going to prove that for you using principle of mathematical induction. Okay, so here's the proof. First of all, we set things up. For each natural number n, we let P of n be the following open sentence. Every bag of n stamps which has at least one red stamp in it must consist of all red stamps. And we're going to use the principle of mathematical induction to prove that that's true for all n in the natural numbers. All right, so let's begin with the basis step. Basis step is that I have to prove that the result is true for n equal to 1. So that means we have a bag that contains one stamp, and we also know that at least one of the stamps in the bag is red. Well, then they're all red because there is only one stamp, and we've said that it's red, and so P of 1 is necessarily true. Now we go over the inductive step. So give ourselves a natural number, and suppose we assume that we're assuming that P of n is true, and we're going to try to deduce that P of n plus 1 is true. So that means we give ourselves a bag having n plus 1 stamps, and assume that at least one of them is red. Now what you do is you remove one of the stamps from the bag, set it aside, and make sure that you're not going to remove the one which we know to be red. Now we have a bag, it's got n stamps, at least one of them is red, so by the inductive hypothesis we know that all of the stamps in the bag are red. Now of the stamps currently in the bag, we can take one of them out. Since they're all red, we'll just make sure that when we remove a stamp, we're still leaving a red one in there. And we're going to replace the one that we just removed with the one that we put aside a few steps ago. So now once again, we've got a bag, it's got n stamps in it, at least one of them is red, so by the inductive hypothesis, they're all red. In particular, the stamp that we removed originally and just put back in the bag must have been red. So now we verified all n plus 1 stamps are red, and therefore we've deduced that P of n plus 1 is true. So we now have the right to say that it follows from the principle of mathematical induction that P of n is true for all n in the natural numbers. Well, clearly there has to be a mistake somewhere in the proof, either in the basis step or in the inductive step. There's certainly nothing wrong with the principle of mathematical induction. So the question is, where's the mistake? So the exercise here is for you to find the flaw in the above argument. The reason that I think this is an important exercise is that it's a mistake that students often make when they're writing up their inductive proofs. And it's a mistake that, of course, I want you to avoid. Of course, typically I'm going to be giving you something to prove by induction which is true, but there's still no justification for using a flawed proof for proving something that is true. You can't claim to have proved it if you're using a flawed argument. So I'll leave it for you as an exercise to figure out where the mistake in the argument is.